Good afternoon, everybody. Today we're going to look at heat and stoichiometry. So you're going to need to go ahead and pull out your packets and turn to page 8. You will also need your calculator today. So go ahead and get that out while you're digging for page 8 in your packet. We are back with stoichiometry again in this chapter and its relationship to heat calculations. So we're going to look at each of these problems to show you how to intertwine the two concepts, and then we'll stop and give you some time to practice on your own. So if we look at this sheet, the very first problem addresses the question of how much heat is transferred when 9.22 grams of glucose in your body reacts with O2 according to the following equation. So they've provided us with the equation for sugar plus 6 O2 gas molecules, and our two products are 6 carbon dioxides and 6 waters. And then we see delta H is negative 2303 kilojoules. So the first thing I want to go back and review before we start setting this up is, what does this value for delta H tell you about? If delta H is a negative value, what type of reaction do we have? Do we have something that is endothermic or exothermic? So if delta H is negative, that tells us we have an exothermic reaction, which means we could also write the word heat on the right-hand side of the arrow, or the product side. All right, so back to our problem here. What we do know is that we have 9.22 grams of the sugar. It's the only piece of information we have, so that's where we're going to start. So that was C6H12O6 times slash. So we're at a point where the only other thing we know about a gram is its molar mass, which is grams per mole. So we're going to get rid of grams and convert to the unit of a mole, because then we can use our balanced equation to change our compound. So for every 1 mole, we need to find the mass of the glucose molecule. So remember that there is 6 carbons. We have 12 hydrogens, and we have 6 oxygens. Each carbon has a mass of 12, each hydrogen has a mass of 1, and each oxygen has a mass of 16. So if you were to pull out your calculator and compile that mass, what do you get? All right, so you should have gotten 180 grams per mole. All right, so our next step is then to figure out how much heat would it take if we had 1 mole's worth of sugar. So according to our equation up here, for every 1 mole of glucose, we have negative 2303 kilojoules. So our conversion is, for every 1 mole, there's negative 2303 kilojoules. So let's go ahead and punch that into your calculator. And True, how many sig figs can we keep? 3 would be the correct answer. However, your calculator says negative 117.96 kilojoules. So if you take that to 3 sig figs, we're going to say 118 kilojoules. and that's negative 118 kilojoules. That tells us that we have energy that's being released from this reaction. All right, let's look at our second equation. And it wants to know how much heat is transferred when 147 grams of NO2 is dissolved in 100 grams of water. So just like our last problem, you start with what you know. The only piece of information we have to go off of at this point is the 147 grams of NO2. So 147 grams of NO2 times slash. So now when we look at this problem, our delta H is a positive 138 kilojoules. This tells us that delta H having a positive value means that it's an endothermic reaction. This would be the same as instead of having this numerical data, that you actually wrote the word heat as a reactant. So what we're going to do is start with our grams of NO2, and let's go ahead and get out of grams, and the only thing we know is how to go to moles. So just like the last problem, we need to find the molar mass of NO2. We have nitrogen and we have oxygen in this formula. There is one nitrogen. Each nitrogen has a mass of 14. We have two oxygens, each with a mass of 16. So that should give us a total mass of 46.0 grams in every 1 mole. Now we're up to the point in which we can use our stoich skills on our balanced equation to set up the last relationship. According to our equation, we have 3 moles of NO2 and if we were to consume all 3 moles of NO2, this amount of heat, or positive 138 kilojoules of energy. So that becomes our numerator. We're back to the point where we can punch this in our calculator. We get to keep 3 sig figs, 147 kilojoules. That's how much energy would be absorbed if we used 3 moles of NO2 for every 147 grams. All right, so at this point, we're going to have you flip back towards the homework section of your packet. There are 10 problems that are there for you to complete with heat and stoich. I've asked the sub to come around the room the last 5 minutes of class and to check off how many of those 10 problems you have completed. You need to show the work for how to calculate delta H in the same fashion that we did our notes.